right, ladies and gentlemen, good morning again. Here we are. Are there any comments or questions about anything so far before we dive into today's material? Anybody have anything they would like to mention? Yes?
When my partner and I were trying to print out just some text statements in Python, we were trying to, I think, just label like the student's average test score was
Okay.
variable.
Mm-hmm.
We used the correct syntax. Our TA said it was correct as well, but Python continues to print both the parentheses and the quotations around just our text, and no one there seems to know why.
Okay, so without seeing exactly what you had, I can't comment on exactly what you did, but it's probably, there are a couple of things. It depends on whether you wrote code in the code window and then executed it, or whether you just wrote expressions in the console window or the shell window or the interpreter window. That'll sometimes leave the quotation marks around things. And if I had to guess, I would guess that if you say hello here, you get the quotation marks. And if you say print hello and then run this, there's a hello without the quotation marks. So we'll see this, bunch of examples of this as we go on, probably even today. But my guess is that maybe that's the source of the issue. Not necessarily. Okay. We'll see if we can clear it up by going through what we're going through today. Go ahead.
Does it matter if you double quotes or single quotes?
Okay, short answer to the question is it does not matter whether you use double quotes or single quotes. You can use either one in Python. Other comments or questions about anything so far? Yes? Well, you can't start something with a double quote and end it with a single quote. You can have double quotes and then a word with an apostrophe in the middle. That's kind of why they let you use both. Yeah, go ahead. Spaces sometimes matter. So spaces matter inside text, right? If you have a sentence, you have spaces between the words. So inside the data, spaces matter. And spaces matter in some places in Python code. I think we'll just see where that happens. I mean, it's not too hard. It's kind of obvious where it shows up. Okay, other things. We're going to dive right into Python from point number one. So if you have sort of small Python questions, they'll probably get answered as we go along. But if there are other comments or logistical or administrative questions or anything else, let me try to answer those now. Yes? No? Okay, so first thing is, let me adjust this a little bit. All right, so the first thing is, if you've started doing the Python part of this week's lab, this is something you're probably familiar with. If not, you will be starting now. The Python interpreter, the Python shell, the Python console, it's called a lot of things, but the window where we see Python do what we want it to do is shown on the left here. In idle, it says Python shell at the top. And in idle, we can have one or more files into which we type Python code, and then we can run that code. It is possible, as I did here, to type Python and to type data and to type expressions into this window, and you get them evaluated right away. But a lot of times people find that kind of confusing, partly because of this where are the quotes and where aren't they and so on. So we're just going to follow the practice always of typing our code over here in a file and seeing what it does when we click run. over in the console window. So, all right. So that's the navigation here. I will be typing over here. I'll click Run. We'll see what Python does with what I run. And that way everything I type on the right-hand side gets saved in that file, which I will mail to you after class. Okay? I won't mail to you a copy of the console window because it'll be long and messy and a pain to follow through. And since you'll have this file with most everything that we type in class, you'll be able to recreate it if you want to. Of course, when you see the recording, right, the UCI replay recording, you'll see everything that goes on the screen, so it's not as though that's lost. All right, so let me say another thing about programs and how we prepare them physically. Our focus is going to be on writing code in Python, right? Writing statements in Python in the programming language that do stuff when we run them, when we execute them. But you don't write programs only for computers. Your code is also going to be read by people. In our context, it'll be read by your lab partner, it'll be read by your TA, but in the real world, it's read by your colleagues at work and maybe your supervisors and maybe auditors and maybe who knows. So when we write code, it's not enough. I mean, it's essential to have the code perform correctly, produce the right answers given whatever data we give it. So correctness is essential, but that's not the end of the job. It also has to be readable and understandable by people. And so we have choices of the names we use and choices of how we format things to some extent and other things that we do just as part of the programming process that are intended not for the Python interpreter to execute instructions, but for the human reader to understand what's going on. So one such thing is a comment. So in our code, from time to time, it's helpful just to leave a note for whoever comes after us. And one way of leaving those notes is to type them after a pound sign, a hash sign, a number sign, a sharp sign, whatever you want to call it. Wherever you type that on a line of Python code, everything to the right of that, the Python interpreter ignores, but it's there with your code so a human reader can read it. So I have one piece of Python code here, a call to the print function that prints out the string hello. I've run it a couple of times already. But I have two comments, one that just gives the day and the date in the class, and another one that says what a comment is. And that'll help me make annotations as we're going along in class too, so that you'll have some notes as usual. So comments, we can have another comment at the end of this line. Okay. You'll also notice it's not that easy to see on this screen. The color fidelity in this projector isn't that great, but you'll see it on your own machines when you do your work. That Python colors the text depending on what part of speech it is that you're writing. And that's something you can mostly ignore. I mean, you don't have to think about it consciously. But you'll find as you go along that it helps you kind of know what you're doing to have these color patterns going on. So, so the color differences aren't random. they indicate different parts, and so you can see the way I have it here, a kind of deep red is the color that they use for comments. I think the way idle is set up by default, comments are a brighter red, but they're harder to read on the screen, so I darkened everything up a little bit. Okay. Okay, there's one other thing that we can do if we want to have multiple line annotations. So if I want to have a bunch of lines, which we'll do when I'm kind of giving you notes on things to put here, we can use triple quotes, quote, 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 and then everything is just gathered together and not processed until we get the next triple quote. There's a little more to say about that, but for now, that's just something that you'll see in these notes. So there we go. All right. Comments or questions about those little details as we get started? Okay. Remember, the story is you don't even have to wait for me to ask if there are comments or questions. If there's something you'd like to hear me say again or say differently or explain further or whatever, raise your hand, wave, say question, and I will get to you. Yes? Well, the quizzes are self-graded. That is, you get credit if you do it, and you don't get credit if you don't do it. And everything else is you're looking at the answers and seeing whether you understood what the question was or not. Yeah?
Can you put the print function, the multiple line annotation side of the print function with a print?
Yes. So triple quoted strings are strings, so I can say okay, so yeah, I've got to turn that off. And there we go. So we have the hello from up above here, and then we have this multi-line string with carriage returns in it, and the triple quotes allow us to do that, just to lay it out this way. So, we don't use triple quotes a lot, but if we have text that we want to print that's multiple lines long, we can use the triple quotes just to type it line by line the way we want the line breaks to be. Okay? Yeah?
If we had 9 quotations while any word, would that print 3 quotations or 7 quotations?
So what if you want to print 3 quotation marks? Is that your question, for example?
Like 9 quotation marks, what would that print?
Well, so I can double quote them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whoops. Okay, so here are my 9 quotation marks here that I just put in double quotes. That's one way to do it. Probably the easiest way to do it. I think we can do it if we want 9 double quotes. All these little pathological cases, there's a variety of ways of doing them. I think we can say / quote and whoops. Yeah. So the / is called an escape character, which says treat the next thing as a literal thing and not as the end of the string. So in this last string here, I have the double quote at the very beginning after the left parenthesis, and I have the double quote at the very end, right before the right parenthesis. And then inside, I have 9 escaped double quotes, each one of which says to Python, hey, just take this as a double quote. Don't take it as the end of the string. So da, 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 there they are, and they show up. Okay, that's the answer to the question. Yes?
I was wondering, in C++, there's like the backslash n and the endl commands. Is anything like that in Python as well?
Similar, yeah. So backslash n is one way to show a new line, for example. Yeah. Right. If I used with the shopping list here just double quotes, whoops, stop that. If I use just double quotes, I'm going to get in trouble because my string doesn't end on the same line I started it on. So we'll see what happens. Here it is. EOL for end of line while scanning string literal. One of the things you will learn as you learn to program is how to interpret error messages. Right? This error message actually tells us what we need to know, but of course you need to know what the terminology means to interpret it. And part of learning programming is not just learning how to write code to do stuff, but learning what the appropriate terminology is, because that helps you understand error messages, helps you understand reference materials, it helps you talk to other people about what's going on in your code. And so, part of being a professional in any field is knowing the terminology of the field. EOL end of line says it ran into the end of the line while it was scanning a string literal. Literal means a quoted character string. We also call those character string constants. So a string literal is we literally print out the letters like HELLO in between the strings. So string literal or character string constant, that's what we've been printing here so far. And Python was scanning through this string constant, and it hit the end of the line and said, wait, it didn't finish. Triple quotes say keep going and take the end of the line and make that part of the string. Without the triple quotes, we run into this trouble instead. Okay. Whatever the question was. Great. Other, yes? There's no difference. You can use either. Basically, there's no difference. I mean, the textbook, I think, says, if it's shorter, use single quotes. If it's longer, use double quotes, because maybe there might be an apostrophe in the middle. There's no hard and fast rule. You can use either. Yeah.
I tried to do a quiz last night. There were no questions.
Okay, so you have to read the instructions of the quiz, which says click here to get the questions. And the questions will come up in a separate window. The questions are on one side, and you put them in one window, and then the quiz form on EEE is just for the answers. That's why. Okay. Great. Other comments or questions so far?
You had a variable string and you tried to do multiple lines, like you did with the print.
Oh, yeah, sure. So let's see what I want to do here. Let me get that away so I don't keep getting that error message. But I can give a name whose value is just this string, triple quoted string, and now I can print out the message. And there it is. So this last message here, we got just the same thing again. Okay? So yes is the answer. Yeah. You first.
How does it count the string length when you use multiple lines like that?
That's a good question. We haven't seen the length function yet, but we will sometime soon, and it tells you how many characters there are in a string. What if there's a new line? The new line character, like the carriage return character, counts as a character. So each new line is one more character in the string. If you use your word processing program, there's usually a setting that will make visible invisible characters like spaces and tabs and new lines. And they show up in blue or something at the end of every line. There's a little kind of curvy deal. And everywhere there's a tab, there's something. And everywhere there's a space, there's a little blue dot or something. That's the way a lot of word processors do it. And that way of looking at things or thinking about things is the way Python counts characters. There's another one somewhere here. No? Oh, great. Good. Okay. Yes? Uh-huh. Well, so one thing I can do is just print nothing, and that'll give me a blank line, because every time we there's the blank line. Every time we print, we get a new line, even if we don't print anything. So we could be a little more explicit about it and print a new line character. This will do exactly, whoops. This will do exactly the same thing. Right, with, not exactly the same thing. I got two blank lines because I get the new line plus the new line that I got just for the print statement in the first place. So anyway, that's how we get extra blank lines, if that's what we want, by print statements. Okay. All right, so enough said, I think, for formatting output. We'll come back to formatting output in a few weeks. Making the output look exactly the way you want it to look is something that can occupy a lot of time, and in the real world that's important, and in our world it's sort of important. But we can't spend all our time polishing the spacing on the second day of class. We have to talk about all kinds of other things besides. So unless there's something hugely pressing about this, are there other comments or questions other than about how we print out strings and how we make them spaced out the way we want and so on? We'll get to all that in great detail as time goes on. All right, then let's keep going here. So there's a term, the term abstraction means simplifying or removing unnecessary detail. We do this all the time, and we sometimes use the term model for the abstraction. So, for example, a road map is an abstraction or a model. The road map models reality. Right? I mean, there are roads and things in reality, but we can't carry the roads with us, and we can't carry, well, we could carry an aerial photograph, and that would be one model. But the aerial photograph, you know, if what we want to do is figure out directions to go somewhere, to drive somewhere, an aerial photograph is probably too much of the wrong kind of detail, right? The aerial photograph doesn't tell us the street names. The aerial photograph, if there's a lot of overhanging foliage, the aerial photograph might not even show us the street, because from above maybe it's blocked by the trees. So we have a road map instead, which leaves the trees out, and leaves the buildings out, and leaves the lines on the pavement out, and leaves a whole lot of things out. It simplifies the real world to include just the details to get our task done. This is something we do, human beings do to solve problems all the time, is eliminate the unnecessary details and focus on the important details. That's what we do when we write software. Right? When we write software, we're building a model inside the computer of whatever real-world thing it is we're building the model about. Now, real world is a little bit of a broad term. If we're writing a computer program to play some fantasy game, right, the monsters that are in the game, I mean, they don't exist in the real world, right? There aren't any real monsters, but they exist in the world outside the computer. They exist in the game designer's imagination. And so still, we're trying to build software that reflects the game designer's imagination in the computer. Right? So that's what software is about, right? Software is building a model of the real world or of the outside world. And we build that model using the building blocks that we have in software. So in the real world, we have things and we have actions. We have things we can do to those things. And same thing is true in software. And that's what we're learning when we learn a programming language. We learn what kind of nouns and verbs we have and what kind of grammar we have to combine them into sentences and paragraphs and novels and anything else. So it's that analogy is a pretty tight one, a pretty good one. We need to figure out a way to build the model we need using the building blocks that our programming language has. So the things we use, we typically call them objects, and the actions can be a lot of different things. So the actions can be statements, or operators, or functions, or methods. Okay, so we'll see examples of these as we go along. But if you think about everything in terms of the things and the actions, that's the overall organizing concept. So any programming language has a variety of these things built in. And a way to combine them, right? And in a way, that's what programming is, right? Figuring out how to use the tools we have and how to build up new blocks, bigger special blocks to represent the things that we need to represent in our software. Okay, so let's say that we want to do a simple computation, as we might have in any restaurant, to compute the total bill in the restaurant with tax and tip, given the base amount of the bill. Right, that's going to be our task. And so we're going to do this task with input and output here in the Python shell, that's pretty much all the context we're going to do this quarter. We might do a tiny little bit of graphical things every once in a while. The problem is there's a lot of stuff to learn before you can do anything cool. Next term in ICS 32, there is more graphics and more graphical user interfaces and other kinds of things, but we're going to keep it simple for now. So this is our task. And let's do it this way. Let me comment out all of this hello and cake making and whatever. So that we don't have to see that anymore. One of the nice things about double quotes and single quotes and being able to use both is that you can have tripled single quotes and tripled double quotes, and you can use them together in the right way. So we have a lot of things here in this code that we've already looked at that's triple quoted out, right? I mean, here's one triple quoted thing, and here's another triple quoted thing, and here's a triple quoted string that we give the name message to, and then we print that out. So we have all of those, and if we tried to put triple single quotes at the top and at the bottom, we'd get confused, right? Because you would start enclosing it in a string, and then you'd find the next step, so three quotes would be a mess. But we don't have any tripled double quotes, so I can put 3 double quotes here, and all the single quote, triple single quotes, and regular single quotes, and regular double quotes, they all just get part of that, and then a triple double quote here, and that's the end of it. And we can see that it looks as though it worked because everything in here is green like a string, and there aren't any other colors like active code. And we can run this once just to make sure that we don't get anything funny, and we ran it and nothing came out. So now the decks are clear for us to start doing what we're doing. So let me just write some code here, a few lines, and we'll add to it as we go. So okay. Let's leave it at that for the moment. All right. So here's some code. Doesn't quite work. There's one thing missing that some of you who've been pushing ahead might recognize, but it'll be close. So let's run it. Okay, first it asks for the name, and when we say input, the shell pauses until we type something and hit return. So we put in a name. What's the amount of the total bill? $100. And it says, I will compute the overall total on $100 with tax and tip. So it hasn't done any computation yet. We'll add that. But these are the steps. So this print statement, just one quoted string with an apostrophe in the middle. Nothing funny about that. The input function, as we just said, waits for the user to type something and hit return. And whatever the user types before the return is captured And that's the value of the input function, which we then assign to a box in memory called name. Right? So one kind of statement, one kind of action in Python is an assignment statement that has the name of a box in memory and an equal sign and a value. You have to be a little careful if you are thinking mathematically. When you say mathematically something equals something else, that's a statement. Maybe it's true, maybe it's false, but it's a statement that's either true or false. Either the two things have the same value. Now, that's not what this does, not what an assignment statement does. An assignment statement says, calculate the value on the right-hand side of the equal sign and store that value in the box named on the left-hand side. Another way to say that is bind that value or associate that value with the name on the left-hand side. So we give things names. It would be better to say make name equal to what we get from the input. Not they are equal, but make them equal. The reason they use equal signs goes back 60 years to the first high-level programming language, first programming language in this category. And the first programming language in this category was called Fortran, F-O-R-T-R-A-N, which was a contraction for formula translation. So they had assignment statements in Fortran that looked more or less like this assignment statement, something equals something. And they used the equal sign because, the way they were thinking of it at the time, they were describing mathematical formulas and executing them. Would have been better if they had used a left-pointing arrow. That would have made the function clearer. But in the input devices they had at the time, there were no left-pointing arrows on the keyboard. You pretty much had the alphabet and the numbers and a handful of punctuation marks, and that was it. So we've kept that convention to this very day. Right? So assignment statement, it has an equal sign in it, but that doesn't mean equality. It means make the thing on the left equal to the thing on the right. And that's what we did. The thing on the right is what the user typed, in this case Donald Duck, and the thing on the left is, the thing on the left is the variable that gets that value. So, one thing we can do in the shell here is look at the values of things. So the value of name is Donald Duck, and the value of total is 100. Okay. So then we print out another line. What's the amount of the total bill? Still one string with an apostrophe in it. We wait for the user to type something. We take what the user types. We put it into the variable named total. We just saw that that's what's in there. And now we print out three things. This double-quoted string, the variable total, and this double-quoted string. So the one thing that's new here is that we're printing out the contents of a variable. We're looking up the value that we associated with this name and printing that value out. So if I were to run this again and say $50, I'd get a $50 here instead of $100. That's why we have variables. If we didn't have that, it probably wouldn't be practical to use a computer at all. So here's the result of that. It all gets strung out on one line. If we have three different things to print out, the first double-quoted character string constant or string literal that goes here, then the variable, then the third thing, and so we separate those with commas. First one, comma, second one, comma, third one. Okay? So we have to have that because we don't, what would happen if we put double quotes around total? Oops. Right. If we put double quotes around this, it's a string constant, it's a string literal. We'll just print out TOTAL, which is totally not what we want. And let's go over here. Right, I typed in the 100, but I said print out quote TOTAL unquote, so it prints out TOTAL, and that's not what we want. Okay, so that's why this has to be a separate item in the list of things we're printing out in the print statement. Okay, so whoops. All right, there we go. So now we at least got the thing we typed in. Yes? Yes. I'm not going to tell you today. 3 weeks from now or so, I'll tell you. It's just one of these tiny little formatting things that we could spend our life on. But yeah, absolutely, there's a way to do that. Yeah. Good. Other comments or questions so far? Yeah. Yeah, we haven't gotten to that yet. You're absolutely right. So remember I said if momentarily a little ways back that there's one bug in this code. It hasn't shown up yet really, but it will as soon as we start doing some arithmetic. And so I'll wait until that happens and we'll go into it. Yeah. What is, it's a mistake. Right? It's just a typo. I presume that, I must have done that after running this, because if I ran this, I would get a message. Whoops. All right, so it says, again, error messages are, you're not going to believe this, but it's true. Error messages are your friend, right? Because programs can be wrong without giving you an error message. That's a lot harder to figure out than if you have a message that points you to where the problem may be. Now, programming language interpreters, they're tolerably sophisticated software, but they're not really that smart, right? And they don't always know what was in your head. They sometimes try to guess, and they'll give you their best guess. They're not always right? You can't just sort of look at the message and do what it says slavishly, but it does point you to where Python had a problem, and that's usually enough to give you a clue for how to fix it. Certainly, if you were to go, excuse me, if you were to look at this and say it's complaining about total M, and you look at it in the code and say, well, wait, this is clearly wrong, this is just a mistake, and it would be easy enough to fix it. But the things you get here, right, looks like a lot of jumbly stuff, but there's a fair bit of useful information even at this moment. It tells us what file of code we're working in. We only have one file, and most of what we do all quarter will be just in one file, but here's the name of it, right? Same name as up here. And what line in the file, so that we can, here's my cursor on line 69, which it says down here. And it gives me the statement that it's complaining about, so here it is with the M. And it says what it thinks the problem was. This name error, the name total M is not defined, which it's not. Right? We define total over here by saying that's the name of where we want to store the second input, but total M, never heard of it, and so it's saying, I don't know what's going on, and you, as a human being smarter than Python, would look at it and say, oh, typo, and fix it. Great. Other comments or questions so far? Okay, so let's see where we are then. Okay, so we print out what percentage chip would you like to leave. We ask the user, and then we rip rate but tip rate. We read the input. And now we can do some calculations, right? So we can say the tax amount is, instead of getting it from the input, I mean, we could make the user do all the work and bring out their own calculator and just type the stuff in. Seems a little silly, right? So we can do a calculation, and the amount of tax is the total bill times the tax rate, which is 0.08, I think, around here. And then the tip rate, the tip amount is the tip rate right. So if we've asked them to leave whole number percentages, 15, 18, whatever, the amount of tip is going to be that over 100, right? Shift the decimal point over 2, so 15% is 0.15. We're just going to be nice and not make the user type the decimal point. If the user types the decimal point, things will get screwed up. But we've told the user the form of input we're expecting. So if the user pays attention to the instructions, then taking that, dividing it by 100, then multiplying that by the total, that gives us the tip amount. And then okay, and this is almost good enough. Not quite, though. All right. All right, we got an error. We got an error, and the error is type error, can't multiply sequence by non-int of type float. Well, so what's that? That's drawing on a little more knowledge than we have, but I'll tell you what the issue is. If you've started doing anything with input, you've already run into it yourself, I'm sure. Programming languages can't tell numbers from non-numbers. Right? Even if there are digits in them and just digits in them, or just digits and a decimal point, or just digits and a decimal point and maybe a minus sign in the front, right? We would look at that and say, oh yeah, that's a number, no problem. Programming languages aren't that smart. Right? Everything in most conventional programming languages, everything that you read in using an input statement comes into your program as a string, as text, as characters, whatever keystrokes on the keyboard were typed, those keystrokes on the keyboard, they get stored as a string. Well, strings are fine if all you want to do is read them in or print them out or do the other manipulations you can do on strings. But if you want to do arithmetic, your programming language needs to store that number in a different way. It can't store it as a string. It has to store it in a different form. The different form is an interesting topic of conversation that maybe you won't hit until you get to ICS 51. But it's not the same as a string. And so in programming languages, we have nouns, and there are different kinds of nouns. And you can only do certain things to certain kinds of nouns. I mean, that's not so strange in the real world, right? I mean, you can drive a car and you can't throw a car. There are certain actions you can do with certain things and certain actions you can do with other things. And arithmetic you have to do with numbers, and what we get from input isn't a number, it's a string. So we can actually tell that using the predefined function type. What's the type of name? it's a string. Tells us that in a little bit obscure way, but str for string. And total is a string, and well, the other ones we haven't really figured out yet. But tip rate also a string. So what we need these things to be is numeric, and all we have to do is say, hey, that string you read in, turn it into a number. Not quite all we have to do. We have to do a second thing, which is we have to say, what kind of number? Right? It's not enough that you have to distinguish numbers from text in programs. In most, not all, but most programming languages, you have to distinguish numbers that have decimal points or could have decimal points in them from numbers that are just whole numbers. And so in Python, as in many programming languages, we have integers called ints, and we have numbers that could have a decimal point in them that are called floating point numbers, which goes back to obscurity, to history for why that's the name. But that's what we use. So what we need to do is, if we want an input to be treated by Python as a number, we have to say turn it into a number. And since we might have a dollars and cents amount with a decimal point for the total, we want that to be a float. And we say float of whatever we get in. So I'm going to add something here. Right. The type of the total is going to be float now, not string the way it was before. This isn't going to be enough to solve the whole problem, but we'll get close. So beg your pardon? Well, the name isn't used anywhere in the code I've written so far. So at this moment, yeah, it's pointless. If I were to add something in the code that used the name, that would then no longer be pointless. So I'll do that after I finish what I'm doing here. Other comments or questions so far? Yeah. If I put int, I would have a little trouble because I'd have a little trouble if I type in a decimal point, because ints don't have decimal points in them, and even if they have the sort of equivalent value. And so taking this string and converting it to an int, I would get some kind of error message. We'll try that too if you remind me in a minute. Yeah. Have to be a little louder, sorry. Oh, so that I can show it to you when I run this, just so that I can illustrate that now total is a different type. Right? I'm going to take it out in a minute. That doesn't have anything to do with the task that we're trying to perform, but I put it in momentarily just to show you what's going on. So in fact, we're running it at the moment. So the amount of the total bill, there we go. And here's the answer. Now total is a float, so that's good. And we get, I'll compute the overall, same as before, 20%. And so, I got a different message. It says type error, unsupported operand types for slash. So we haven't explicitly said this yet, although we've kind of been doing it. But one kind of verb is a statement, like an assignment statement. Another kind of verb is a call to a function. That's what print is. It's a command that's predefined in Python. Another kind of a verb is an operator, like plus or asterisk for multiplication or slash for division. And so it's talking about the slash operator, the division here, because I didn't make tip rate a float, right, the way I did here. I didn't do that yet here. So tip rate is still a string. So trying to divide that string by 100 doesn't make sense, and that's why I got the error message. So Slash is an operator, an arithmetic operator, and the things on either side of an operator are called the operands, and that's what it's saying here. Unsupported operand types. So the kind of thing we're doing slash on isn't supported. It means you can't do it. You can't throw the car. You can't divide a string by an int. So that's the right answer. I mean, they're complaining about the right thing. So let's fix that. Right? We already demonstrated that. So let's turn this one into a float. And now this is a number which we can multiply. This is a number which we can multiply. This is a number which we can divide. And these are all numbers which we can add together. So we should be okay. Let's see. Keep hitting the wrong thing here. Okay, so the total to pay is $128. This is a formatting issue, right? So we need to know how to print out dollars and cents amounts with 2 digits to the right of the decimal point. We will learn how to do that, but not today. Right? A whole 45-minute conversation, which now is not the right time for. So don't worry about that. The amount is right. It just looks funny, and there's totally a way to deal with that. We just don't know it yet and don't have time to learn it right now. Otherwise, though, we can be pretty confident that this is right. We can take out a calculator and do it, but by choosing round numbers, right, we can sort of verify in our head that this is the right answer. 20% of $100 is $20. There's the $20, and 8% of $100 is $8, so there's $128. We will talk not too long from now about other more thorough ways of demonstrating that our code produces the correct results, because that turns out to be important. Right? If your code doesn't work, it doesn't matter anything else about it. If it doesn't produce the right answer, who cares how fast it is or how long it is or how big it is or how anything else. If you don't get the right results, it's just pointless. So, there's a further discussion that we'll have about testing and getting things so that we're confident that our code works. Yes?
When you turn the value into a float, it accepts both integers and decimals?
Yes. So floats, integers, right? So floats contain more than integers. Or real numbers, right? I mean, a float is what a mathematician would call a real number, and integers are part of the real numbers, right? So, yeah.
When you're naming a variable, is there any way to explicitly define its type? So when we're making names, could we say this is a float?
Good question. Not in Python. In many other programming languages, that's the practice. Python doesn't make you, depending on your point of view, but you don't do that in Python. You can just use it and put something into it, and whatever type you want to, you put in. That makes it quicker, but it deprives Python of the opportunity to check things earlier on. So Java, for example, is a programming language where you do have to say for every variable you use what type of thing you're going to put in it. And if you do that, then the Java compiler can look at all your code and make sure that all the things you're doing are being done with the right types, and it'll check that as it translates your program in the first time. Downside, you've got to put all the types in. Upside, a whole category of errors, because you're forced to include that information, the programming language checks for you. So, Python was designed to make it easier to get code written more quickly, and Java was designed to be heavier weight and, in some sense, safer. But it's only a timing question. It's not as though Python doesn't check. It checks when you try to do something, and if it's the wrong type, it says, doesn't make sense, can't do it. That just happens while your program is executing, while you're actually carrying out the instructions instead of earlier. Now, other programming languages, like C and C++, they don't check either on the front end or on the back end. They just assume you knew what you're doing, and they take the internal storage and they do the arithmetic operation. Even if what you put there were letters, it's all bits in memory, and they just let you do it, figuring, hey, you're the programmer, you knew what you were doing. I'm not going to charge you for making that extra check. I'm just going to assume you did the right thing. Well, I mean, there are trade-offs there too, right? I mean, it's a very interesting question. So we could talk more about that, but I think we won't. Go ahead.
Since we were assuming that they were going to give an integer for the break, could we have converted that into an integer and still had it work?
Yes. So that would have worked fine, right? I mean, I could have said int, and as long as what they type is an int, an integer, doesn't have a decimal point in it, that would work fine. The way we've done it here doesn't hurt, and if they say 15.5%, we can let them get away with it. So sort of either way. All right, I promised to do a couple of things. One thing I promised to do was to use the name. So why don't we just do this? Okay, so we'll print out the name, and then a comma, and the total to pay is blah, blah, blah. Let me just run that so we're confident that it works. Okay, so Donald Duck, the total to pay is $158.13. And so now I use the name, so we don't have to feel as though it was worthless effort. There is this space here. There is this space here. The way this turned out, we have exactly 2 digits, but we haven't resolved that issue. We haven't resolved the space here. There are resolutions to all these things. Another day, not today. Okay, I promised to do that. I forget what else I promised to do, but I do want to do one other thing. And that is, yeah, because I want it to print out. So this comma here that I want in the printout, I have to have in the quoted string to get it printed out. That's separate from the comma after name, which just separates this item I'm printing from the next item I'm printing, from the next item I'm printing, from the last item I'm printing. So this comma is inside the quotation mark, and it shows up right here in the output. Okay. Other comments or questions so far? Yes? Okay, what happens? Good question. Let's run it and see. All right. Blammo. Value error could not convert string to float. Here's the string. It couldn't convert that to a float, right? We typed in tip 15%, couldn't convert that to a float because it has all these other things that aren't digits, and we got the message. Okay, great. Yeah. I'm sorry, it's a little louder. Okay, so there is a mechanism for snagging errors like this in your program and then handling them. And that mechanism is called exceptions, and that's something that we won't learn this quarter, but you'll learn in ICS 32. Okay. Yeah.
Is there a function that checks if a string itself can be converted to a float?
Yes, and we'll talk about that sometime before the quarter's over, not right now. But yeah, you can read in the string, and then you can check to see whether it's all digits, and if it's not, you can deal with it. And that's probably the right thing to do in a professional quality program, right? In a professional quality program, we wouldn't have messages like this. We would have something that at least gives the user another chance. So your impulse is right. That's what we'd want to do. And today we're not going to talk about how to do it, but it's not unduly hard. Good. Other comments or questions so far? Yes.
When defining variables, are the variables case sensitive?
Yes. So uppercase letters and lowercase letters are different, and they're different to Python. If I said capital N name here, it would say, I've never heard of capital N name. So yes, it's called case sensitivity, and it matters. Other comments or questions so far? Okay, let me do one more thing. See this number here? Right? That's the sales tax rate. And sales tax rates change from time to time. Imagine that this code is not the 10 lines or so that it is, but it's a more realistic sized program of 10,000 lines or 10 million lines. And buried somewhere on one of those lines is the sales tax rate. It would be hard to find. Imagine, in fact, that we use the sales tax rate not just in one place, but in 5 different places in that 10,000 lines of code. What happens when we need to update the sales tax rate? We need to find all 5 instances. Now, we could do a search for 0.08, but maybe we have other things in our program that are also 0.08. We might change the wrong thing. Or we might have typed it in some places as 0.080 and or 0.8 maybe. We might have typed it in a way that find and replace won't snag it. So what we're thinking about here is not even how our program works at the moment, but how our program is going to work in the face of inevitable changes in the world, right? We're modeling the real world. The real world changes. Software has to change to reflect that. And so when we talk about good programming practices, a lot of them are so that we can make those changes easily when the time comes, and we don't leave ourselves open to potential errors. And so one way to do that is to give a name to these constants so that we can see more clearly what they are and have just one place to change them. So we could say we can give this a name, and we can just say tax rate here. And if we needed to use that tax rate somewhere else in this hypothetically much longer code, we could do that, and we would just say tax rate. And then when the time came, if we needed to change it, we'd have one place to change it, and it would be reflected everywhere. So that's a general good practice in programming. We call this a symbolic constant. It's constant because we're not going to change this in our program. We're just going to leave it at 8%. And it's symbolic just means that it has a name a symbol that's easier to remember and recognize than just the number. So this doesn't change the behavior of the program, but it changes the behavior of the software development team when the sales tax rate goes up or down. Okay? And so, general rule, if you have plain old numbers in your program other than 1 or 0 or 100, right? I mean, we don't need to have a constant for 100 to figure out a percentage. But anything else that conceivably might change, give it a name and use the name. Okay? All right. I think that's that. Other comments or questions about this code so far? Yes? Yes. So the question is, can you input other files of code into your main file of code? Yes. So if in a large software system, you would have different parts of your program in different files, and you would somehow have to gather them all together. And there is a mechanism for doing that in Python, which we'll see a tiny bit of, and you'll see more later.
For the tax rate variable, is there any way we can make that a constant, like by typing so it's unchangeable in the code?
Good question. Could we do something about tax rate to make Python give us an error message if we ever try to change it in our code? And the answer is no, not in Python. There are programming languages where you can do that, but Python's not one of them. Yeah.
Is there any way to use Ethernet to refer a tax rate to, or is that not possible?
Is there any way to do?
Get the tax rate from.
Oh, very excellent question, right? So the question was, instead of just putting the tax rate in our program, can't we go, plug across the internet, find the California Franchise Tax Board page, look up Orange County, and pull the tax rate out of that, and then always be using the official source? The answer is yes. What you need to do is find out how in Python to go make network connections, and then how to download the page, and then how to pull the particular tax rate you want out of that page. I mean, there's a certain amount of tedium to it and a certain amount of specialized knowledge, but it's totally the right thing to want to do for a professional quality program. And again, that's not something we're going to do this quarter, but probably next quarter in 32, something like that you will get to do. Yeah, if I just want to clear this up, I'm sure there is, and I just don't know what it is off the top of my head. I don't remember. I can stop it and start it up again. There's probably some other way. I just don't remember. Okay. Other comments or questions so far? Yes?
Is there any syllabus that we can go visit to see all the symbols, such as the hashtag or the print?
Well, there should be reference pages in either of the textbooks. If not, I'm sure there are online at python.org. And there are other reference kinds of books. The thing is, it's nice to have the list for reference, but it's nice to have that. And if Perkovich and Ziante don't have those, they probably should. It would make it a little bit easier. Great. Other questions so far? A couple more things to do. Yes? Okay, so names of identifiers, names that you can choose, have to start with a letter. After the letter, letters or numbers or underscores. Actually, underscore could start with an underscore too, which is a little weird, but sometimes some things in Python do that. So letters or underscores with numbers after the first character. Great. Other comments or questions so far? All righty. Let's just see where we are here. All right, let's do this. So All right, what are the things, what are the nouns and objects that we've done? We have variables. Actually, let's start this way. We have ints and floats and strings. We have variables. We have expressions like taking two variables and combining them with operators. And we have variables, and the sort of opposite of variables is constants, right? So quoted things or numbers that just are raw numbers, those are constants, and things that have names, they're variables. And all right, and so the verbs we've seen are the function Okay, so we had three different functions. We have operators, multiply and divide and add. I don't think we did any subtraction. And I think that's it. So that's what we've learned so far. We'll learn some more things on Thursday and take it from there. Okay, thank you all very much. You can come and ask me. Just come on down and ask me. Oh yeah, type. I forgot about that.
Oh, okay. So I can add type.
Sure, yeah.